We've talked about conditional statements. Today we're talking about biconditional statements. Let's first go over these few vocab words. The first two, I'm hoping you guys know these. Guys, with your arms, show me. Stretch it out. End of the day, almost. Perpendicular lines, show me with your arms. What do they look like? Shout it out. What exactly does the measurement have to be? Has to be 90 degrees. So sketch yourself a picture. Now they're lines, so make sure they have arrows. Guys, I told my 7th graders that on tests I'd mark you guys wrong if you don't put your arrows. They thought I was so mean. Alright, put your arrows on there. Put your little symbol. Has to be 90 degrees. Perpendicular means they cross each other at 90-degree angles. Okay, think about this. Guys, if this one is 90 degrees, what's the angle across from its vertical angle? What does that have to be? Next to it has to be. Yeah, they're all 90-degree angles. Yeah, thumbs up, that makes sense. Okay, next one, I've confessed I'm not very good at drawing planes, so do your best. A plane is like a piece of paper, so I'll just draw it a little bit sideways. So this one, a line perpendicular to a plane. So this would be like a pencil busting through a piece of paper right at 90-degree angles. Good luck drawing it. So I just draw a line coming down, maybe it's hitting it right there. Once it cuts through, it's underneath. So my dots to show underneath, and then it's coming out the bottom of the paper. But if it's 90 degrees, make sure you get that symbol on there. So the 90-degree angle would be right here where it's touching the paper and going through it. That's a line perpendicular to a plane. Okay, biconditional statement. So it's a statement, we've got a sentence, and then look for these 4 words. How many words, guys? 4. The statement has to have if and only if. If the sentence has that in the middle, if and only if, then it's biconditional. Okay, will you sneak in one more? This is a reminder vocabulary word. Well, words. Sneak in conditional statement. Okay, that was a bit confusing, sorry. Alright, here we go. Biconditional statement, conditional statement. Conditional statement only needs 2 words. Do you remember what it needs? Yes, it's if then. So that's the difference between biconditional and conditional. Conditional has an if and a then. Biconditional has if and only if. Literally, it has those words in it. Alright, let's go to the next. Okay, will you try this on your own? Read what's going on, look at your picture, see what you think about A, B, and C. So this first part, letter A, says that angle KLJ and KJL are complementary. Guys, I beg you, on tests, on assignments, trace over these so you know exactly what angle it's talking about. So KLJ, it's a map. So start at K, go to L, and then to J. Oh, so that's the 36-degree angle. Okay, and then KJL, trace it out. Start at K, but then go to J, and then L. Oh, okay, so that's the 54-degree angle. Is this complementary? Okay, shout it out, guys. What number stands? Well, complementary stands for what number? Shout it out. 90. Yes, so add those together. 36 and 54, do they equal 90 degrees? Yeah. Sure do. So this one, true. Just raise your hand if you put true on letter A. Let me see. Good job, good job. All right, letter B. So I'm going to erase this on the board. Letter B is talking about perpendicular lines. And you are more than welcome to trace on stuff. You can trace on your assignments. You can trace on pictures on the test. So KL's right here, right? And then LJO, right there. Is true or false? What'd you put for B? Totally false, right? That is not a 90-degree angle. Once you highlight it, it seems like it's obvious. Okay, last one. Let me erase this. So our last one, what were we talking about? Angle MKG. Where is it? Start at M, go to K, go to J. Oh, true or false? This is the right angle. What did you guys put? True. Totally true. It's a vertical angle, right? Perpendicular lines. Cut those lines into 4 right angles. How many got all 3 of those? Let me see. Perfect. Okay, let's keep going. So we're at the top of your next notes. Next page uses the same picture. Try this on your own, okay? I'll watch the clock. I'm only going to give you about 35 seconds. Okay, pause this. Okay, here we go. Number 1, true or false? Shout it out. Ready? Angle KJL is an acute angle. What'd you put? True. Absolutely, because what degrees does it measure?
Less than 90 degrees.
Less than 90, and specifically it's 54. Good job. Thanks, Colton. All right, number 2, I'm curious. How many of you put true on number 2? Let me see. How many put false? Nice. How come? So I like to color over these. KLJ. So it's all of this, right? Oh, totally. That is absolutely on the exterior. So that was Big Ten faults. Yeah? Okay, let's keep moving. I need to learn about those biconditional statements. Okay, here we go. Rewrite the following biconditional statements. Stop. Right now, how do you know this is biconditional? What 4 things are in it? Kelsey. If and only if. This is what's making it biconditional. It literally has to have that in the sentence. So we've got to rewrite it as a conditional statement and its converse. Stop. Conditional statement has to have 2 things. What 2 things does it have to have? You can shout it out, guys. Has to have an if and then. Okay, let me give this one away since this is our first one. So conditional statement, if always goes at the beginning, it's our hypothesis. So this one, if an angle is a straight angle. Stop and think about that. Where did I get this from the sentence? Where is it in the original biconditional? It's at the beginning. If should come from the beginning, okay? So take the beginning part, put that as your if part. If an angle is a straight angle. All right, let me give away the last part. Then its measure is 180 degrees. Take the last part and make it the then part. Okay, the next part is the converse. Because do you remember what the converse is without looking at that reference sheet? Do you remember what we do to the conditional statement? Colton, do you remember?
Was it squiggle or
Squiggly P, squiggly Q, so negate the P, negate the Q. I don't think it is. I think that's the inverse. What do you think it is, June?
Isn't it just Q?
I think it is. Is it, guys, Q then P? Does anybody have that reference sheet out? So conditional statement, our hint on our reference sheet is start with the hypothesis, and then converse is do it backwards. Conclusion to hypothesis. Is it? Yeah, switch. Okay, here we go. So this one we would say if an angle measures 180 degrees, or if the measure of an angle is 180 degrees, same thing. So we start with the last, end with the first. Then the angle is a straight angle. Because this is really similar to your assignment. Your assignment will give you a biconditional. You have to rearrange it to a conditional and then do the converse from a conditional. Okay, let's move to the next part. The next part we're deciding, is this true or is it false? Are you ready? Okay. Whew, here we go. Consider the following statement. X equals 2 if and only if 3x plus 5x equals 10x minus 2x. Yada yada, right? Okay, the first one, not too bad. Letter A. I need a hand in the air. Is this a biconditional statement? What do you guys think? Tyler, what are you thinking? Yes, it is. How come? Why do you think? That's all you have to check for, isn't it? Like the sweetest question ever. So yes, because it has if and only if in it. That's all you have to check for. Okay, letter B is going to take some work. Because letter B asks, is the statement true? Because we hold up 2 fingers and wiggle them. This is why this is tricky to check for trueness. You have to see if the conditional statement is true and the converse is true. It takes work to see if it's true. You can't just like, probably true, slap on true. You have to rewrite the conditional, rewrite the converse. If they're both true, they're true. Okay, hold your heads, I'm going to confuse you. Are you ready? What if you get the conditional is false and the converse is false? Guess what? The biconditional would be true. Oh my gosh, did I just confuse you? Okay, so biconditional statements, in order for them to be true, the converse has to be true. But the conditional, the original statement, has to be true also. Then the biconditional is true. Can you at least follow that one? This is the weird one. Are you ready? If the conditional statement is false and the converse is false, what about the biconditional? Weird, right? We'll get into that later. Just teasing you a little bit. We'll get into that later. Okay, here we go. So conditional statement, let's rewrite it. So take the first part. So the first part is x equals 2. So right here, let's put if x equals 2. And then take the last part. Then 3x plus 5x equals 10x minus 2x. Okay, let's stop right there and decide if this conditional statement is true or false. So it's saying start. Start right here. I'm going to tell you the answer. The answer, x equals 2. Let's stick it in. Are you ready? So right up here. So we're going to take that 2 and put it everywhere we see x. So guys, what's 3 times 2? Check. What's 5 times 2? Okay. Oh, Lord. Oh, man. So we've got 6 plus 10 equals, over here, 10 times 2, 20 minus 2 times 2. Okay, is this true? 6 plus 10, does that equal 20 minus 4? We're good, so the conditional statement is true. You with me? Whew. So check, we know one of them is true. Now we have to see if the other one is true. The next part, converse, just flip it. Put this 3x plus 5x equals 10x minus 2x first, and put this x equals 2 last. The converse is just switching them. Okay, so if 3x plus 5x equals 10x minus 2x, then x equals 2. How many of you beat me to that one? Did you do it before you got on board? Thank you. Okay, so keep telling you, because I'm bragging about you all the time at your algebra skills last year. So part 2, using your. So this one is saying start with this equation. Start with this equation and let's solve it. You have a tiny bit of room at the bottom of your notes. Will you follow me on this? So we've got 3x plus 5x equals 10x minus 2x. True? Okay. Now let's just solve it. We did this a lot when we were going through our proofs, our algebra proofs. Let's combine like terms. So 3x and 5x, we've got 8x. Yeah? 10x minus 2x, what the 8x? You with me so far? What would you do next if you were doing your algebra skills? Christian, what would you do?
I would like, if I knew what x was, I would times it by 2.
If you knew what x was, you would times it by 2. So right here, we know that, right? That's what we should get at the end. But remember, like our proof, we had to get all the way to that part. So we should get to x equals 2. Maybe? Let's keep finishing this, though, like it was our proof. What would you do next on this? Colton, what would you do?
8x equals 8x. That would be x.
X, where'd the x come from? What are you doing?
You're just taking away both of them at the same time.
How do we get rid of these 8's, guys? Okay, let's divide by 8 on both sides. So that would be the division property. So what the, we've got x equals x. Oh, Kelly, what did you just say?
That could be any number and it would work.
Any number works in this. If you stick a 1 right here, does 1 equal 1? 2 equals 2. 0 equals 0. 100 equals 100. We can put anything in here. Do you believe it though? Let's put zeros up here. 3 times 0 is plus 0. Right? 0 equals 0. What about 1? Maybe that's too obvious. 3 times 1 is plus 5 times 1. Okay, so that's 8, right? And then 10 times 1 minus 2 times 1, 8 equals 8. We can put any number in here. So this is saying start with this equation, solve it. You should get 2. Did we get 2? We got any number works. So this is false. The converse is absolutely false. First statement we got true. The conditional statement is true, but the second statement, the converse is false. So the biconditional statement is false. Weird, right? Yes, Allie.
So if the conditional and converse are the same, like they're both true, both false,
Mhm.
then the biconditional is true?
Yes, Allie said, so if the conditional and converse are both true, biconditional is true, yes. If the conditional and converse are false, then the biconditional is true. I think that's the weird one. Okay, let's keep going on our notes. You're doing great. Okay, here we go. So we've got this going on. First, what we're supposed to do with letter A is write the converse. It starts with if square root of x equals 1, then x equals 1. Can you write the converse? Can you fit it in that little blank spot? Switch it. A. Let's start with A. So we're talking about solution A. Okay, easy enough. So switch it. We would say if x equals 1, then square root of x equals 1. I like these better than the other version. I like when they start with the answer, because that means you can plug in the answer. So take this one, put it right there. And they gave it to us start off. We didn't have to solve for it. So if you put the one inside, struggling. If you put the one inside right here, because what is the square root of 1? So what about the converse? It's true. That one they gave the answer to us first so we can stick in the answer. Next, you just have to write a biconditional statement for it. Okay, show me how many fingers, how many words does it take to make a biconditional? Yes, 4. Thank you so much. Do you know where to put it though? Okay, it goes right in the middle. Start with your hypothesis, and then put the if and only if, and then end with your conclusion. So go back to the original. Hypothesis was square root of x equals 1. So we'd say square root of x equals 1. Then we slide in if and only if, our biconditional part. End with the conclusion, if x equals 1. Okay. So square root of x equals 1 if and only if x equals 1. Okay, you ready to go on to letter B? Letter B is totally different from letter A. So letter B is saying if two angles are vertical angles, then they are congruent. What do you think about that? True or false? If two angles are vertical, then they're congruent. Definitely true. That's the definition of vertical angles, right? So this conditional statement is true. But what do you think about the converse? So right here, in this part, flip it. And then let's talk about the converse. So switch the conclusion with the hypothesis. Okay, so this one is saying if two angles are congruent, then they're vertical angles. What do you think about that one? Just because the angles are congruent, do they have to be vertical angles? Nod your heads yes or nod your heads no. What do you think? I'm seeing lots of no's. So I put this example up on the board, and I think I included it on your notes. Do you guys have this picture on your notes? So these two angles, 45, 45, are they congruent? Absolutely, they're the same measurement, right? But are they vertical angles? No. They don't have to be. Congruent means the same measurement. Literally the same angle measurement. So this one, the converse is false. There's a counter example out there for us. Okay, last part. This is very similar to your assignment, so will you try this next part on your own? I think they give you a biconditional. You've got to write a conditional and a converse. Yep, they start with biconditional. So guys, right here you have to do a conditional statement. So go back to your if-then form. And then do the converse of that. And then number 4, go on to number 4 because that's asking letter A and letter B about these two statements. Go, try this on your own. A conditional statement, raise your hand if you got this same thing. If two angles are supplementary, then the sum of their measures is 180. Yeah? Okay, nice, hands down. All right, raise your hands. What about the converse? If the sum of the measures of two angles is 180, then the angles are supplementary. You okay with that? Okay, yada yada, right? All right, letter A and letter B, I like these ones a little bit more. Letter A is a giveaway, guys. How many of you got yes on this one? It had that giveaway if and only if, right? All right, letter B, is the statement true or false? How many of you got true on that one? Forwards, backwards, it's true. Guys, good job. Okay, let's stop and let you work on your assignment.